Hello guys, welcome to Design by Solidworks. Today we're going to continue the 3D sketching part. In the previous video we learned about how to create a projection curve, a 3D projection curve, and today in this segment we're going to learn about how to create a helical curve or a spiral curve. Okay, so you can see in the feature command manager in the curves, see this is the option helix and spiral. We have already come across this option when we created threads in nuts or bolts. You can refer to the video 19 when we created threads along a nut or a bolt. Okay, so let's get started with a helix. So what does this helix and spiral curve option does is, this is generally used to sweep path to create springs, threads, spiral coils, etc. Okay, so let's first select this one. Okay, helix and spiral. See, the message is select a plane on which to sketch a circle to define the helix cross section. That means we first need to select a plane here and we have to draw a sketch. A sketch is mostly a circular sketch, a circle. Okay, so let's draw it. Select the front plane, create a circle, let it be 50 mm. Okay, now exit the sketch. So you can see the property manager, this is on the left hand side. Okay, the first option is defined by, this is selected as spiral, so in the preview you can see the spiral curves are created. Select pitch and revolution. See, these first three options are for helix and the last option is for spiral curve. Pitch and revolution means you can define your helix via pitch. You can define the pitch and you can define the number of revolutions in your helical curve. Come to parameters. See, constant pitch and variable pitch. Constant pitch means the height between two parallel circles right here, this one and this one, this height will be similar, same for all. That is called pitch. Constant pitch means the height will be same throughout the helical curve. In the constant pitch you can see some options: pitch, revolutions, start angle, clockwise, counterclockwise. Okay, pitch means you can define in this spinner the height. If I select this as 20 mm, see the height reduced to 20 mm. It was previously it was 34 mm. Okay, see, reverse direction means this is a circle and in this direction the helix is created. If I select this button, see, the direction is just reversed. Second is revolutions. This is the number of revolutions. See, 8 means the 8 circles are created like this. If I go on increasing this, see, the number of circles are increasing. Now decreasing. That is the number of revolutions. Start angle means, see, this is starting from this angle right now. This is 180. If I select 90, then it will reduce to 90 degree. It will start from here. Okay, let's select as 90. See, it started from here. Okay, from this line, 90 degree. And the next option is clockwise and counterclockwise. That means the curve, it is created like this. in a clockwise direction. See, like this. Okay, see, it is created in this direction. This is clockwise direction. If I select this, then this arrow will opposite direction. See, like this. It is now counterclockwise, anti-clockwise direction. Okay. If I select variable pitch, see, with this option I can vary my pitch between two parallel circles right here. So these are some options you can see. First, second, third, and here I have to define the pitch and then the number of revolution, the total height and the diameter. Okay, suppose I select this as 20 mm. Okay, see, the number of revolutions, sorry, the pitch is decreased. Number of revolutions 8. I can also change this, like if I select 6, see, now 6 circles are here. Height is reduced, and I can also select the diameter. It is 50. If I click OK, it will create a pitch like this, but this is a constant pitch. Okay, now select another. I want to create a pitch of 50 mm and 5 revolutions. Okay, I have to put greater than 6. Okay, then 9. From 6 to 9 the pitch will be 50 mm. Okay, now you can see now this is clear. You can see from this point to this point up to 1, 2, 3, 4, 5 and 6. After 6 revolutions the pitch is 20 mm as we defined, and then after 1, 2 and 3, this line, the pitch is 50 mm as we defined right here. So with this variable pitch option you can vary the pitch of the spring coils according to your need. And this reverse direction means it will, the direction will get reversed. See, like this. Similar start angle, like we have seen in the constant pitch, it will is now 90 degree. It is from starting from here. If I select it as 0 degree or 180 degree, it will start from this line. Okay, then the clockwise and counterclockwise option. Okay, if I select OK, see, a helix is created according to our need, according to the inputs we have given. And you can also create this helix by other options, like go to edit feature. See, here in the defined by options type you can also select height and revolution. Here you have to give the height, the complete height from this end to this end, the complete height of the spring and the number of revolutions. The pitch will be automatically divided if you give constant pitch option, and if you give variable pitch option then you have to define the pitch like in the previous pitch and revolution type. And at pitch and height type this is the same. You have to define the height and the pitch. The number of revolutions will be divided by height to pitch. If we select the constant pitch option, if we select the variable pitch option, then we also have to set the values manually, the height, pitch, revolutions and diameter, and other options are similar. Okay, So let's now see the spiral curve. Okay, if we select spiral, see, like this. Spiral is actually a planar curve. You can see we created the circle right here, and the circle we created in spiral curve, this is the starting point of the spiral curve, the starting diameter. Then you can see in the parameters pitch, reverse direction, number of revolutions, start angle, and the option clockwise and counterclockwise. In the pitch, you can define the pitch between these two parallel circles, the distance between. If I increase this, see, the distance is increased. Number of revolutions, see, like this. Number of spiral will increase, and this one is the start angle, similar to the helix. We see if we select 180 degree, then see it came to like this, here to here, this straight line, 180 degree. And this is a spiral curve on our screen right now. Okay, let's go back to edit feature. See, in the constant pitch option, you can see another option right here, taper helix. So what do you mean by taper helix? Taper helix means, see, it is very small. Let's give a taper angle like 20 degree, greater than, equal, less than or equal. See, the message is showing please enter a number greater than or equal to 0 degree and less than or equal to 7.125 degree. That means the number of pitch we have given, the height of pitch, and the number of revolutions we have given, the taper angle cannot be more than 7.12 degree. So let's select 5 degree suppose. Okay, see what happened. You can see easily, right? At this diameter the helix started, and the diameter go on decreasing up to 0 and this angle with the vertical is 5 degree. That is a 5 degree tapered helix. You can also select this taper outward option, that this diameter will go on increasing, see, like this, rather than decreasing. That's the tapered outward, and this is the tapered inward option. Click OK. Now you have a tapered helix like this. Okay. So these features are mostly used for sweep path, to create some threads, springs, coils, and okay. So that's it for today, guys. In the next video we will start the assembly part of the Solidworks, assembly modeling, and see you in the next video. Thank you.